Hello, everybody. Guys, today we going to overcome another C hurdle, C challenge, and it's a race. So let's talk about them. Array is basically a package of variables. So all the variables in array, they have the same name, but we identify them through the indexes. So what I did here in my small demo program, I created two arrays, small one, line 7, and big one, line 16. Array can be integer, can be double, can be character, any fundamental type. And what I did, I created in line 8 a double array, and it consists of 3 numbers. So technically speaking, you could put the size of the array here, but I don't do that because it may be wrong. So don't use literal as a size of your array. So let compiler calculate how many items in your array. You can use the formula, by the way, in order to understand how many elements array has. You may divide the size of the array by the size of one item. So this is much safer. So don't use literals for integer literals for array sizes. It's not safe. Instead, you can count the number of the items using a simple formula. This way, if later on you modify your array, you add new numbers or remove some numbers, your program's still good. You don't have to change anything, and new size is going to be automatically adjusted. Don't forget, the first element in the array has index 0, and the last element, the length -1. So in my case, the last element, 3.3, index is not 3, it's 2. So this is maybe the most common mistake beginners make. They think the last element of the array is the length of the array, which is not true. As a result of such a mistake, they trying to access memory outside of the array, and the program may crash unexpectedly. So be careful. First index 0, last index length -1, and then I'm looping. I'm going through all my array items, but in line 13, I'm using just classic syntax. In order to access array element, I'm using square brackets. But in line 14, I'm using an alternative way to access array elements, because the type of the array identifier is a pointer. So basically this identifier is pointer to double. So in line 14, I'm using dereferencing operator to access array elements. Of course, line 13 is easier to understand. It is shorter, but it is important to understand you have two different ways to access arrays in C: through the square brackets or through dereferencing. What if I have a big array? Let's say I have a few hundred items. Of course, I cannot initiate them using curly braces, obviously. So in such a situation, again, I don't use literals. It's not safe. It's hard to modify such a program. If you use as a size of your array a literal, you may end up having in your program lots of those literals, and later on you have to change all of them. So the safer technique is to create a constant. So you can use preprocessor in C, and instead of number you can use a symbol. And now I don't use literal, I using just a name. So I created array, big one now, line 17, but right now the values of the array are random. It can be any numbers, and I did some cleaning. So memset, it's a library function, and it is to clean the memory. So I put 0 in my array. Memset working with the bytes, so that's why I calculated how many bytes I need to clear using a simple formula. And then what I did, I'm using again pointer in order to put in the last array item number 99. So line 19, pointer is used to access the last array element. But in line 20, I'm using a standard technique, standard way to access array elements through square brackets. Let's compile. Let's check if everything is working. Let's run it. And what I see is small array was initiated. I printed, if you remember, each item twice using classic way and C way. And then I created a big array, 300 items. I put 99 to the last element, and I printed. The most common problem you have with the arrays in C, they allocated during compile time. So you cannot put as a size of your array a variable. It is not allowed. You have to count how many items you need ahead of time. So the size can be literal or symbolic literal. And if you don't know how many you need, you allocate the maximum. So you may waste a lot of memory using arrays in C. Sometimes we call them static. Static arrays are defined at compile time. So how to overcome? Let's take a look at the second program. If I don't know how many items I need, if I want to allocate my array dynamically during my execution, a runtime. So in line 8, I ask the user how many items he needs. I got it, line 9. And then using library function calloc. Calloc stands for clear and allocation. So you asking some memory from operating system, and you clear the memory. So everything is zeroed. So, and the result is the address of the array, and now it's on the heap, dynamic area of the RAM. By the way, if the result is null, that means system couldn't allocate memory. I don't check right now if it's null or not null to make my program shorter. So I allocated as much memory as my user asked, so I don't know ahead of time. Then I'm looping. And look, in line 12, I'm just using standard syntax. So I'm treating my dynamic array the same way I'm treating static array, using square brackets. And then I print all the elements in line 13. The most important thing with the dynamic memory, you have to free dynamic memory. You have to return it back to the operating system. So line 15 is very important. And beginners very often forget to free dynamic memory. We call it memory leakage. Very common problem. You borrowed some RAM, but you didn't return it. So that's a very simple demo of dynamic array. So let's try it. I'm going to now compile. No errors, and I'm going to check how it's working. So how many int do you need? Let's take 10. So you see memory allocated, numbers are saved in dynamic memory, and then memory was freed. You may ask, by the way, what if I allocated dynamically some memory, but it happened to be not enough? Well, you have two choices now. If it's not enough, first choice, you can allocate more memory, and then you copy your old items to the new memory and you free the old memory. Or there is another function in a standard C library, it's called realloc. So it may let you add to the existing memory more memory. So thank you very much. Today we talked about a typical C hurdle or C challenge. It's one-dimension arrays with one index only. Of course, arrays with two indexes also very popular. Two dimensions arrays, they also very common. And we are going to discuss them later on. Thank you very much. I appreciate your likes, your subscriptions, and all the best.